Hello, I'm Alexander Lewis, and today we'll be solving this problem. We are rotating the region bounded by x equals y minus 2 squared, the x-axis, and the y-axis about the x-axis. So the first thing we will note is that we are rotating the region. The region that we are rotating, the bounds of it are x equals y minus 2 squared, the x-axis, and the y-axis. The second thing is we are rotating about the x-axis. So we notice that we have f of y rotated about the x-axis. Since the variable of integration, y, is opposite to the axis of revolution, of rotation, x, we're going to use the shell method. So that implies that we'll be taking an integral, or 2 pi times the integral from a to b of the radius, which is y minus axis, times the upper, times the height, which is the upper, and the function difference, which is, and since there's one function and the lower bound is the axis, it's just this, and then dy. We found these bounds because of here you plugged in 0 and found that the upper bound is 2, so y equals 2. So the bounds are y equals 0 to y equals 2. And then we come over here to this integral, so 2 pi times the integral from 0 to 2, sorry, that's a 0, of y3 minus 4y squared plus 4y dy. This came from factoring y equals y minus 2 squared. You separated that out and then foiled, and then you multiplied the extra y in. So you have y3 minus 4y squared minus 4y dy. Then you evaluate this. You take the integral of each part and evaluate from 0 to 2. So you plug in 2, and then you subtract, when you do this minus plugging in 0, but when you plug in 0, all of these become 0, so it's really just minus 0, which is just this. And then it's 2 pi times that, which is 1/4 times 16 times minus 4/3 times 8 plus 8, which then becomes 4 minus 32 over 3 plus 8, which becomes 2 pi times 12 minus 32, which becomes 2 pi times 36 over 3 minus 32 over 3, which becomes 2 pi times 4 over 3, which becomes 8 pi over 3. So your answer is 8 pi. The volume is 8 pi over 3 units cubed.